Hello year 11s, welcome to the next class. Okay, so we're dealing with 14J today. So what we're doing is we are drawing our trig graphs. Okay, what we're going to do is we're going to add plus or minus b. Okay, and what this is vertical translation. Okay, so a sine graph can be moved up, it can be moved down. Okay, so it's just going to get increasing complexity as we move through this chapter. Okay, so what we've got is I've got a sine graph there. Okay, so y equals negative 2 sine 4x plus pi on 3 plus 5. What we need to is describe. So we're going to list all the possible transformations that we have. Okay, so what I'm going to do is at the start, I'm going to start with the ones on the outside, the easy ones. Okay, the first one is we know the amplitude. Okay, the amplitude is 2. Okay, nice and easy, just that vary. What we have is that negative sign. Okay, that is actually a separate transformation, and that is a reflection. Okay, around the x-axis. Okay, on the outside, okay, over there with the plus 5, we actually have a vertical translation. So we have a vertical translation of 5. Okay, 5 upwards. Within this graph, okay, so within this graph, it looks like we've got a translation of pi on 3 to the left, okay, but remember that you need to take the 4 as a common factor. So 4 bracket x plus pi over 12, okay. So that pi on 12 is a horizontal translation. Okay, horizontal translation, and because it's positive, it's going to move to the left, okay. So pi on 12 left, okay, to the left, okay. So you can write that. I'm a little bit lazy today, okay. Just remember when we're drawing our sine graphs as well, okay, so as we have our sine graphs, remember they traditionally look like this. What we're doing is our middle value, because we've got a vertical translation of 5, it's actually moved up, everything has moved up 5 units. So what we can do is we can draw this again, okay, but in this case, so that's my x-axis, and this is my y, okay, I'm going to list that as 5. So what we've got is, as I draw that there, that's our, it's not an asymptote, okay, so don't get confused, that's an asymptote. That's our sort of our mean, okay, so you'll see that as like our sine graph, okay, that's our mean. So what happens is, with our sine graph, okay, because it's reflected as well, so we're going down, so actually it looks something like this, okay, and what you'll find is that your lowest value will be at positive 3, okay, and your maximum value will be 7. So we can actually list a range, okay. So for this, our range is actually equal to 3 to 7. And notice I've included those values, okay. That's included, okay. So that's all the transformations that we have. So we've actually got one more. Our periods changed, okay. So that 4 that I'm circling there has changed our period, okay. So calculate our period. Okay, remember, it's 2 pi over n, which is 2 pi over 4, which is actually pi on 2. Okay, so that means that distance that we're saying from there to there for our graph, okay, that's actually pi on 2. Okay, that width. So the width of one full revolution. So it goes down, up, and down, back to its original position. Okay. So next example that we have, we're going to actually draw and sketch something. Okay, so what we've got is sketch the graph of y is 2 sine bracket 2 bracket x minus pi on 3 minus square root of 3. Okay, and we're going to do this over the domain where x is an element of 0 to 2 pi. Okay, so very similar to the example that we did with our last exercise. Okay, so some of the key bits of information that we need to find at the start. We'll start with the easy ones. Okay, the amplitude. Okay, amplitude equals 2. We can find our period. Okay, so period is 2 pi over n equals 2 pi over 2. Okay, so that's that value right there in front of the x, which is actually pi. So when we think about it, we need to automatically think about, okay, now that our period is pi, and I'm doing it over the domain of 0 to 2 pi, I'm going to get quite a few values. I'm going to get more than our sort of traditional 2 when we find our x-intercepts, okay? So that's going to help us draw it, okay? What else we have? We've got our vertical translation, okay? So we've got a vertical, okay? I'll square root 3 down, okay, because it's a negative. And we've also got a horizontal. Okay, and that will be pi over 3 to the right. Okay, notice that we've already taken 2 as a common factor out, so we don't need to do that. The question's been nice too. Okay, so what we're going to do, remember, first of all, I'm going to find my starter endpoints. Okay, so I'm going to put on my y-intercept. Okay, let x equal 0. So y equals 2 sine 2 bracket 0 minus pi on 3 minus square root 3. Okay, so 2 sine, okay, 2 times negative pi on 3 is minus 2 pi on 3. Okay, minus square root 3. So what you find, minus 2 pi on 3, we're drawing our unit circle around, so a quick little short one, we're somewhere over there. Okay, so we're in our third quadrant because we've gone backwards. Okay, so what that is with our third quadrant is that becomes 2 sine, okay, pi plus pi on 3 minus square root 3. Okay, so pi plus our pi on 3 angle. Okay, which becomes, if you look at your unit circle, okay, that little handout that I've given everyone the other week. Okay, what you'll find is sine is negative in that area. Okay, so this becomes 2 times negative. Okay, and sine of pi on 3 is square root 3 on 2. So square root 3 over 2 minus square root 3. Okay, so a bit of math. These two values are going to cancel out. Okay, and what you actually get is, remember, they're like terms, so they're going to subtract each other. So this becomes 2 minus 2 square root 3. So I'm just going to kind of add those two values together. Okay, so just be careful of that. So that's our y-intercept. Okay, so it's a little bit of math involved in that, but we can work our way there. Now I'm going to find my value at 2 pi. Okay, so I'm going to let x equal 2 pi. Okay, so y equals 2 sine bracket 2 bracket 2 pi minus pi on 3 minus square root 3. Okay, so it's a bit to go. 2 sine. Okay, I'm going to simplify. Apologise for the dogs. Okay, so 2 minus pi on 3 is 2 pi on 3 times 2. So that becomes 4 pi on 3. Okay, minus square root 3. And what you notice is that 4 pi on 3 is exactly the same as the one that we did before. So sine 4 pi on 3 ends up being in the third quadrant, and it ends up becoming pi plus pi on 3. Okay, so very similar to the question that we had before. Okay, minus square root 3. And as you can do, I'm not going to do the working out because I know that my answer is going to be minus 2 square root 3. Okay, so I found my starting point, found my finish point. Not too bad. Now what we're going to do is we're going to find my x-intercepts. Okay, so to find my x-intercept, I'm going to let y equal 0. Okay, so to find my x-intercepts, I've got 0 equals 2 sine 2 bracket x minus pi over 3 minus square root 3. Okay, so I'm going to rearrange it. I'm going to bring the square root 3 across, so it becomes square root 3, and I'm also going to divide by the 2 there. Okay, what you notice is square root 3 and 2 should be familiar with our exact values, okay, on our little handout that I've given everyone. So, and that is equal to sine bracket, I'm going to expand this, okay, so 2x minus pi on, minus 2 pi on 3, okay. So what I've got is when I go inverse sine, I'm going to bring the 2x minus pi 2 pi on 3. Okay, that's going to be equal to sine minus 1 of square root 3 over 2. Okay, so remember when we got to this situation with the lesson before, I need to find out how many values that I have. What I need to do that is I need to manipulate our domain. Okay, so I'm going to rewrite that as our domain is 0 less than equal to x less than equal to 2 pi. Okay, I'm going to multiply it by 2 first. Okay, so we're sort of doing it the opposite way to what you'd think. So I'm going 2x is less than equal to 4 pi. Okay, less than equal to 0. And what I'm going to do is I'm going to go 2x minus pi on 3. Okay, so I'm going to do the opposite to what you think. So remember that even though that translation means to the right, I'm going to push the domain to the left because we're going to push it to the right later on when we deal with our math down here. Okay, so what we do is, as I'm going to subtract pi on 3, so if that's 4 pi, that would become, so that's 12. So that equals 12 pi on 3, and I'm minusing 1, so that becomes 11 pi on 3. Okay, less than equal to 0 is minus pi on 3. Okay, so we're finding all our values for sine square root 3 on 2. So inverse sine of square root 3 on 2 is 60 degrees. Okay, so we're trying to find all of our values that would satisfy this, that we get a positive answer. Okay, so as we think of our unit circle, okay, I'll draw it up here. Got a unit circle around there. So we're dealing with inverse sine of pi on 3 is 60 degrees, and sine is positive. Okay, sine is positive in the first quadrant and the second quadrant. Okay, so they're the two quadrants that we really need to focus on. So that negative pi on 3 moves down that way. I'm going to ignore that, okay, because I don't really need to work on that. So my first value is actually going to be pi on 3. Okay, my second value will be the one over here, which will be 2 pi on 3. Okay, I'm going to continue around. Third and fourth quadrant, they're both negative, so I'm going to ignore that. And then I push it up across. So this next one will be, so pi on 3, so that would be 7 pi on 3. So this 6 pi on 3, which is 2 pi, plus the extra 1, 8 pi on 3. And then I continue my way around, and I'm going to stop there. So what I actually have is I have my 4 values. Okay, because if I do a full revolution, my 2 revolutions, that is equal to my 4 pi, but we know that we're just under our 4 pi, okay, at 11 pi on 3. So I've only got 4 values there, and this is equal to 2, I might, no, it's all right, 2x minus 2 pi on 3. Okay, so what I'm going to do is I'm going to bring this up here a little bit, okay, just to give myself a bit of room. And I'm going to start rearranging it, okay, so I've got 2x is equal to, I'm going to add the 2 pi on 3. So pi on 3 plus 2 pi on 3 is actually 3 pi on 3, or pi. Okay, 2 pi on 3 plus 2 pi on 3 is 4 pi over 3. Then we've got 7 plus 2, which is 9 pi on 3. And I have 10 pi on 3. So constantly with this step, I've just constantly added 2 pi on 3, okay, just from this one. And then what I'm going to do is I'm going to divide every value by 2. So this becomes pi over 2, 4 pi on 6, 9 pi on 6, and 10 pi over 6. Okay, I can simplify a few of them. So pi over 2, 2 pi on 3. I've got 3 pi over 2, and what's that, 5 pi on 3. Okay guys, so this is going to finish up my first part of the video, so hopefully the teacher will just change over to the second part. Thank you.